All right, welcome 8th graders, future 9th graders, back to Teaching with T. This week we are going to be focusing on equations with variables on both sides, but instead we're not. Y'all know how I get tongue-tied. The equations are going to have decimals and fractions. There you go. I knew I could get it out. It just took me a second. So the equations are going to have fractions and or decimals. Probably just one. I'm not trying to hurt nobody and have both of them in there. So we're going to focus on that. Now, when you are looking at equations with both sides, so last week we did equations on both sides. This week is the same thing. We have variables on both sides. So we have our variables on both sides, right? When you have fractions, decimals don't have that additional step that I'm getting ready to show you. Fractions, the first thing you want to do is get rid of the fraction. Now you can't just say, snap, fraction, you're gone. Doesn't work that way. You have to use the math to get rid of the fraction or the denominator. You can't just, denominator, go away. It doesn't work that way. I wish sometimes things would just go away, like we could be back in school and I could be showing you this. But that's not the way it is right now. And at this point, it is what it is. So we have to get rid of our denominator. How do we get rid of our denominator? You get rid of the denominator by multiplying both sides by the denominator. So it's kind of like doing the inverse. Remember when we do an inverse? The inverse is what we use to undo something. I have to undo this. How do I undo a fraction? Well, what is a fraction? What type of operation is a fraction? The operation is a division. So how do I undo division? I multiply. Now, most of you had me last year in 7th grade. So I know good and well, I taught you inverse operations. We had them on the wall. We used our feet. We used food. We used our bodies. We used hands. We were all over the place. Inside the tent, outside the tent. We made it work. So I know you know inverse operations. So I'm not going to spend a whole lot of time on inverse operations. We're just going to get right into it. So the first thing, like I said, you're going to do the inverse to get rid of, there we go, your denominator. In this instance, my denominator is a 2. And what I do to one side of my equal sign, I'm going to do the exact same thing to the other so I can get rid of that denominator. So this and this cancel out, right? And this cancel out. Well, let's write it out. Let's just write it out to make sure. If I'm multiplying this times this, I'm saying 2 times 3w, and I'm saying 1, because remember, a whole number, you put a 1 on the bottom. And I keep that there. And then you're going to do the same thing with this one. Plus, because it's still 3w divided by 2 plus 1. You still got to include that 1. Just because it is a whole number doesn't mean you don't include it. You still got to include it. And if you remember, excuse me, I'm going to show you this one here and hopefully I can squeeze it over here. I'm going to have to shove that over a little bit. Well, no, we should be all right. 2 times 1, 2 times 2, all that stuff. So I'll let you look at that first while I get ready to set up the other side. All right, so on the other side, we're doing 2 times w, because remember, this is our distributive property, 2 times w plus 2 over 1 times 9 over 2. All I did was distribute. I distributed 2 here. I distributed 2 here. Okay? Now, essentially, all you're doing is crossing these out. So that is actually the shortcut. So you would end up with 3w plus 1 equals w plus 9. So you would end up there. But what you don't understand, what I want you to see is these constants. This is what changes. Okay? These change. So you could say, well, Miss T, why don't you just cross it out and then I could just write all that? Because if you did that, you would forget that this number is still multiplied by this number as well. And this number is still multiplied by this variable. You cannot forget that. Okay? Uh-oh, my board's moving all over the place here. So if I have 2 times 3w, what am I going to get? Or, before I did that, what would I have? What do I need to do? Right. They cancel out. You simplify it before you even start. Simplify that bad boy. I'm not going to do 2 times 3w and then divide it by 2 and still end up with 3w, because that's going to be 6w divided by 2, which gives me 3w. Why would I do that? Why would I do that extra step? I'm going to simplify them before multiplying them out. 1 times 3w is just a 3w. Right? Yes. Then I have plus 2 times 1, which is 2. And then I have 2 times w, which is 2w. And then over here, remember, cancel them out. Plus 9. Now I have the problem that I'm used to looking at. I'm used to seeing this. Oh, okay, this makes sense to me. Now I know exactly what Miss T is trying to tell me what to do. So you're going to get all of your variables on one side and all your constants on one side. So let's do that. Let's get our variable on one side by using our inverse. These cancel out. I don't want to go through that. And this gives me w plus 2 equals 9. Hopefully I don't run out of space here. Then what? What do I do now? So actually let me do, I'm gonna write it in black. W plus 2 equals 9, because we brought down everything we didn't use. Then I want to get my variable by itself, which is isolating the variable. So after I've isolated my variable by getting rid of my constant, I bring down my w, my equal sign. 9 minus 2 gives me 7. So my final answer, that does not look like a star, so we're just going to get that off of there because that looks crazy. W equals 7. Okay? Now you can check the work. You can put the 7 back into the original problem and say 3 times 7 divided by 21 by 2 plus 1 is going to equal 7 plus 9 over 2, whatever that ends up being. I'll leave that there for a second. We're going to go to another example. You will see this exact example on the notes. I am going to upload that one. I have one other example that I want to show you for decimals, and then I'm going to show you probably in the second video, one that might be a little bit more, 2 that are a little bit more complicated. So the ones in this video are not as complicated. The reason why I'm going to show you the other complicated ones is because I want you to be able to see the difficult ones, Because as you know, as I've said in class, if you can do the difficult ones, you can do the easy ones, okay? So sometimes challenging yourself helps you understand it more and allows you to do any of the problems, okay? So if you need to take a screenshot, I'll let you go ahead. But like I said, this particular problem, all the problems I'm showing you today are going to be on what I upload, the notes. Please do not think that the notes that I'm uploading is the work. It's not. It's not the work. The work is on Khan Academy. All of the work is on Khan Academy, okay? I might throw in a quiz is sometime in the near future just to give you a break from Khan Academy, but just understand that all of the work is on Khan Academy, okay? For the most part. So our next example is going to be on decimals. So I'm going to say 2 tenths, times the quantity of 3y minus 5 is equal to 15 hundredths times, oh, you know what? I'm writing too big. I just realized that that's going to run off. There we go. All right, 15 hundredths times the quantity of 2y plus 3, nope, not equals, minus 85 hundredths. Like, come on, Miss T. I literally can hear y'all saying it right now. Come on, Miss T. Don't you me. You can do this. We're going to do it step by step. Step by step, okay? The first thing I'm going to do is I'm going to do 2 tenths times 3y. 2 tenths times 3y. This times this. And then this times this. Remember our rainbow? This and this, this and this. So this times this gives me 6 tenths y minus 1. Now, you could say 1 and 0 tenths, but it's just 1. Why would you do that? So, I'm not gonna. So, that's just how I roll. 15 hundredths times 2y is going to give you 30 hundredths y. 15 hundredths times 3 is going to give you 45 hundredths. And then I just bring down my 85 hundredths. Okay, so the first thing we did was we did this and we did this. The second thing, after we distribute, so we distributed first, I use my distributive property. After your distributive property, you need to combine like terms if necessary. So on the notes last week, it gave you the 5 steps. Don't look at my nails because I took them off and they're crazy. It gave you the 5 steps. You start off with distribute if necessary. Well, it was necessary for us to distribute, so we did. Then the second step is to combine your like terms, which is what we're going to do here. When we do like terms in class, remember we did different shapes to identify what goes with what. So on this side, do I have anything I can combine? Any terms that are alike? No. On this side, do I have any terms that are alike? Yes, I do. This term right here is a term on its own. These two are different. So that means these two have to have a different shape. Oops. You know, I said you have to include the operation. My fault. Include the operation. So before I do that, I'm going to bring down everything I didn't need to use. And I'm going to stop there. I can combine these two. When I take this number and I combine it with this number, what am I going to get? The best thing to do is to I would say taking things out of the decimals is easier. It's an easier way to do this. The way you take everything out of a decimal is you would multiply everything times 100. So after we get to, I'm going to show you the next step, but once we get down to that next step, we're going to turn everything into whole numbers. So if I say 45 hundredths minus 85 hundredths, I'm going to get a negative 40 hundredths. Okay? Because 85 take away 45 is 40. Then I'm going to take the entire problem, everything, and I'm going to multiply everything by 100. And the reason I'm doing that is because the largest quantity that I have is in hundredths. So because the largest quantity that I have is in hundredths, or technically it's the smallest, but I'm going to say 100. Hundredths, 100, you get it? Tenths, 10, thousandths, 1,000, okay? When I do that, this comes out and becomes 60. It's starting to die. This becomes 60y minus 100 equals 30y minus 40. You see that? So it's almost like the decimals just kind of disappeared and this one added a 1, and one as a whole is 100. Okay. So then I'm going to subtract, step 3, before I talk about subtracting and adding. Step 3 means you need, combine. I don't have it in front of me, y'all, so I'm trying to go from memory. Not combine like, so we did combine like terms. Oh, okay. Get all of the variables on one side. So now we need to get all the variables on one side. And remember, I said, keep your bigger variable, the positive number. So you want to end up with a positive variable. So the number, I'm not going to move 60 because 60, I'd have to do the opposite, which is a negative 60. So then I'm going to get a negative answer because 60 is bigger than 30. Don't do it that way. Take the smaller one because this is positive. Now, if this was negative, then I would move it, but it's not a negative. So leave it alone. I'm not going to move it. I'm going to move what is going to keep my answer from becoming a negative and having to do the calculations to change it. So then we have 30y minus 100 equals a negative 40. Add 100 to both sides. Because remember, Miss T has taught y'all inverse operations. Inverse operations. So then we have 30y equals 60. Divide both sides by 30. I'm going to put my answer over here. And my answer is y equals 20. Nope. 2. I'm tripping. Y equals 2. Took me one hot second to look and be like, wait, that ain't it. Okay. Hopefully I didn't go too fast for you. If I did, then go back through. Run the tape again. This was step 1. This was step 2. This was technically part of step 2. So I'll just put it as step 3, 4. This was the 5th thing that we did, and this was the 6th thing that we did. Now, if you're looking at the notes, then this was 1, 2, 3, 4, 5. So based on the notes, so I'll leave this here. This is just what we did. Based on our notes, this would not have been a step. This was only a step because we had a decimal. This would be 3, this would be 4, and this would be 5. Okay? So as I said, the next video, I'm going to make sure, well, not make sure, but it's going to be a little bit trickier. I'm going to walk you through it, and you'll be all right. See you in the next one, guys.